As we contemplate the sun, we are aware of its enormous power and the energy it emanates throughout our solar system. It is hard to imagine anything capable of surpassing our sun, yet beyond our own star lies a cosmic wonder that makes even the mightiest solar giants seem insignificant in comparison. Betelgeuse, the red supergiant, defies explanation with its enormous diameter, irregular pulsations, and unpredictable behavior. The star is an enigma to scientists who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Join us on this tour as we dwell into the constellation Orion with the James Webb Telescope and explore how its arrival could change our understanding of Betelgeuse and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. Although many people are unaware of this fact, it is possible to spot Betelgeuse in the night sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellation Orion and Canis Major to see this dazzling star in all its splendor. There you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the constellation. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at the star, you will have noticed that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence, since Betelgeuse, as the star is called, is no ordinary star. Although to us it may appear just to be one more in the vast firmament, it is located at a distance of more than 640 light-years from us. At first glance, this figure may not seem impressive, but in reality it represents an enormous distance. To illustrate this magnitude, let's imagine that we could travel at the speed of light, which, unfortunately, is not possible. Even in that hypothetical scenario, it would take us more than 640 years to reach Betelgeuse. If we wanted to undertake such a journey into a spacecraft, even using our most advanced technologies, it would take us more than 12 billion years to reach it. This figure far exceeds the entire history of human civilization on Earth. However, the scarcity of light from Betelgeuse is not only due to the distance that separates us from it. Betelgeuse is what is known as a pulsating red supergiant, which means that it is an ancient massive star that undergoes expansions and contractions. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods, ranging from tens to hundreds of days. The amazing thing is that Betelgeuse can oscillate in brightness over a wide range. It can range from near magnitude 0.5 to reach 0 magnitude, making it extremely bright. These changes follow cycles, with the shortest being 185 days and the longest being 2,335 days at times. At certain times, Betelgeuse can become quite faint, which is called V-band magnitude. In February 2021, it was reported to present its lowest V-band magnitude in a long time, reaching a magnitude of plus 1,614. Although it's relatively bright, it is definitely fainter than how we usually observe Betelgeuse. However, brightness is not the only outstanding feature of the star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface, which has a temperature of about 3,500 Kelvin. This temperature is much lower than the surface of our Sun, which reaches 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. That is why, despite being one of the largest stars we know, it appears much dimmer. Betelgeuse is like that giant that is satisfied with a low profile and doesn't need to show off its size to feel important. However, don't be fooled by her appearance. Betelgeuse is a supergiant star that is about 20 times the mass of our Sun. This is one of the reasons why this star has been the subject of numerous studies. Over the centuries, it has been a prominent object in the night sky and was first identified by the ancient Greek astronomer Ptolemy. His name in Arabic means Orion's armpit. Although not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties, such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Millimeter Submillimeter Array, or acronym ALMA, L-A-M-A, a state-of-the-art observatory located in Chile. ALMA, or ALMA, has provided high-resolution images of the surface of Betelgeuse, revealing details about its structure and behavior. One of the most remarkable discoveries made by LAMA, or ALMA, is the presence of an extensive plume of gas extending from the surface of the star. This plume is believed to be caused by pulsations from Betelgeuse. These pulsations, which can be explained by a process called convection, involve the rising of hot gas and the sinking of cold gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also been obtained, revealing intricate patterns of gas and dust. These observations have allowed researchers to create models to understand the star's behavior and predict how it might behave in the future. In addition, Betelgeuse's surface is marked by dark spots, also known as star spots or magnetic spots. These areas on the star's surface exhibit particularly strong magnetic intensity. These regions, known as star spot, are areas on the surface of Betelgeuse that are cooler. This is because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. As a result, the spots appear darker compared to the rest of the surface. Betelgeuse's magnetic field is believed to be thousands of times stronger than that of the Sun. This intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, describing regions of intense magnetic activity that are visible as star spots. It is important to mention that the presence of star spots is not unique to Betelgeuse, as they are also observed in other stars, including our own Sun. The star spots in Betelgeuse are very especially interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is significantly larger and more numerous than the sunspots on the Sun. These star spots can affect the overall brightness of the stars and cause variations. As the spots move in and out of view, Betelgeuse's brightness can fluctuate. This is because the spots, being cooler, emit less light than the surrounding gas, which contributes to changes in the observed brightness of the star. In the case of Betelgeuse, pulsations of the star also contribute to the brightness variations. As the star expands and contracts, star spots move in and out of view, further amplifying the star's observed brightness. The surprising thing is that Betelgeuse is not as unique as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. One of Betelgeuse's cosmic cousins is Antares, a red supergiant located in the constellation Scorpius. Antares is also a variable star, meaning that it undergoes changes in brightness over time, just like Betelgeuse. In addition, Antares has a mass approximately 12 times that of the Sun and a radius that is 700 times that of the Sun. So, it's safe to say that Antares is no slouch in terms of size.
Betelgeuse, the red star located on the shoulder of Orion's warrior, has exhibited peculiar behavior, which has generated great anticipation for witnessing a once-in-a-lifetime spectacle. Some suggest that the increase in brightness could be indicative of a star approaching its supernova, but when exactly will this occur? Experts speculate that it could be in the near future. Join us as we examine the current status of this star. If you're interested in keeping up to date on news from the universe and its surroundings, subscribe to our channel and be sure to like this video and turn on the notification bell. Although you may not be on a first-name basis, it's likely that you have seen the magnificent Betelgeuse. A glowing reddish dot shines brightly in the constellation Orion. At present, Betelgeuse is extremely massive. In fact, if we were to place it at the heart of our own solar system, its surface would extend beyond the orbit of Mars. This colossal and easily observable star continues to fascinate us. Betelgeuse changes before our eyes because of its relative closeness to our galaxy. It is a semi-regular variable star meaning that its brightness fluctuates, sometimes dramatically, as it moves towards its imminent final collapse in the form of a supernova explosion. In recent years, Betelgeuse has become even more interesting due to unexpected fluctuations in its brightness, which we still find puzzling. Although its behavior in its unknown territory has been strange, its recent behavior is attributed to a phenomenon known as the Great Dimming, which occurred between 2019 and 2020. Due to this event, the closest red supergiant star to Earth is shining twice as bright as usual, illuminating the sky in the early evening hours in the southern hemisphere. This strange behavior of one of the brightest stars in the sky provides scientists with an unprecedented view, as Betelgeuse rapidly transitions from a bright to a dim state of brightness. In recent times, Betelgeuse has sometimes shown an increase in brightness of more than 50%. However, on May 20th, 2023, the Twitter account called BetelBots, dedicated to tracking Betelgeuse using information from the American Variable Star Observing Association, reported something strange: an impressive 142% brightness increase. Astrophysicist Andrea Dupree of Harvard's Smithsonian Center for Astrophysics notes that Betelgeuse currently ranks as the 7th brightest star in the night sky, moving up 3 positions from its usual position of 10th. If you are in the southern hemisphere, you can easily see Betelgeuse shining at dusk. You just have to look for it on the shoulder of the constellation Orion. Even in the northern hemisphere, Betelgeuse can be observed as the days get shorter. A technology researcher from Swinburne, Australia, points out that one of the most fascinating things about Betelgeuse is that it allows us to witness the final stages of a giant star's life in great detail, something that has not previously been possible to study in such detail. By observing the behavior of Betelgeuse, we can gain important information about what happens to red giants before they become supernovae. It is speculated that Betelgeuse could become incredibly bright for a week, even during the day, and could cast shadows in the darkness of night. This phenomenon has captured the attention of amateur astronomers and professional astronomers alike. At some point, Betelgeuse will explode and end its life in a stunning supernova. Given that we are 650 light-years away, we will have the opportunity to witness this amazing cosmic explosion in the best possible way. Heidi Morris, a scientist at Los Alamos National Laboratory and president of the Astronomy Club, says that people are really fascinated by Betelgeuse and have been watching these brightness changes for a long time. Astronomers have long known that Betelgeuse experiences periods of intensity and then fades again. Even ancient Australian Aboriginal and Greek cultures noticed this pattern thousands of years ago. Normally, Betelgeuse's brightness cycle lasts about 400 days, but right now, its brightness is changing much faster, about every 130 days, as observed by Andrea Dupree, who has studied this star. This unusual behavior began in 2019 after Betelgeuse ejected some of its outer atmosphere with force. These brightness changes are not typical for Betelgeuse, but does that mean that this star is on its way to exploding into a supernova? According to a paper written by Dupree and other scientists from Harvard and the University of California at Berkeley, it is estimated that it will be 5 to 10 years before Betelgeuse returns to its normal cycle. The author states that Betelgeuse has not been the same after experiencing the Great Dimming. Since then, it has shown different behavior in terms of luminosity and radial velocity. Betelgeuse still has a long way to go before it becomes a supernova. As a red giant star, it goes through a series of fusion processes involving different elements such as helium, carbon, oxygen, silicon, and iron. When a star becomes a red giant, the intense pressure in its core allows helium to fuse into carbon. The star then continues to fuse carbon and helium to form oxygen, and the cycle repeats, producing heavier elements such as iron and silicon. The progress of these fusion reactions will eventually lead to Betelgeuse collapsing under its own weight due to gravity. The end result could be the formation of a black hole or a neutron star. Based on analysis of the chemicals present in Betelgeuse's atmosphere, it appears that the star is currently in the early stage of this fusion process, specifically fusing helium into carbon in its core. Betelgeuse is a massive red supergiant that has led a fast and intense life. It is currently in the final stages of its accelerated evolution. Eventually, when it exhausts its fuel, the core will collapse under its enormous mass, leading to an explosion that could eclipse entire galaxies. This supernova is bound to happen, but like all the others, we wonder when it will happen. There is much speculation about when Betelgeuse will finally explode into a supernova. However, experts have doubts. University of Portsmouth astronomy professor Peter Grauer, who specializes in the study of supernovae, has written a book on the subject and points out that we currently have no means of predicting when stars will explode. So we have no exact clue as to when Betelgeuse went supernova. It is understandable that this uncertainty is so high, since throughout human history, we have not witnessed many supernovae to study, despite the hopes of astronomers. Given this lack of certainty, we do not yet know if anyone in our lifetime will have the opportunity to witness the spectacular explosion of Betelgeuse.
Are you prepared for what is about to happen? Betelgeuse, a huge red supergiant, the closest to Earth, has experienced a remarkable dimming in recent years, generating mixed emotions around the world. Some speculate that this phenomenon could be a precursor to a supernova, a cataclysmic event that causes concern among scientists and the general public. Betelgeuse, a prominent figure in the constellation Orion, has gained some of its brightness after dimming, but appears to be transitioning to a less active phase. Scientists are concerned about the possible outcome of Betelgeuse's life and whether its eventual explosion could affect Earth. Orion, one of the most recognizable constellations, is known for its two main stars, Rigel and Betelgeuse. Betelgeuse, also called Alpha Orionis, it is the brightest and largest star in Orion. Data collected by NASA's Hubble Space Telescope and other observatories indicate that Betelgeuse underwent a massive mass ejection in 2019, a behavior never before observed in a star of its type. While coronal mass ejections are common in our Sun, this event on Betelgeuse is unique and arouses great interest among astronomers. Betelgeuse corona, however, surprised scientists by ejecting an amount of mass of 400 billion times greater than the average coronal mass ejection, CME. This cloud of hot gas released by the star temporarily covered some of its light, leading to the unusual dimming observed. Although some estimates place Betelgeuse farther away, it could be as close as 724 light-years from Earth. Determining the distances of red supergiant stars like Betelgeuse remains a challenge for astronomy because of its great distance and peculiar characteristics. Betelgeuse is one of the brightest stars in the night sky, being about 100,000 times more luminous than the Sun. However, this intense luminosity comes at a price, as Betelgeuse's immense energy rapidly depletes its fuel, hastening the end of its life. Eventually, the star will run out of fuel and disintegrate under its Sun's weight, possibly giving rise to a supernova and eventually a neutron star or even a black hole if our current theories are accurate. Does Betelgeuse pose a threat to Earth? A supernova outburst a few tenths of light years from our planet would have devastating consequences. When a supernova explodes, it can generate an amount of light equivalent to an entire galaxy, which means that even if the star is relatively close, such as Alpha Centauri, its effects could not be ignored. Since 1604, we have not yet witnessed a supernova in our own galaxy, although in 1987 one occurred in the Large Magellanic Cloud at a distance of 169,000 light-years, with remarkable effects, although it did not pose a direct risk to us. The danger zone around a typical supernova is an intriguing concept that could have serious implications if such an explosion were to occur in our vicinity. However, it is important to keep in mind that, in cosmic terms, Nearby supernovae are relatively small events compared to gamma-ray bursts, which are of a completely different scale and much more powerful. Supernovae are bad news. They have the power to destroy biospheres and blanket the world with lethal radiation. A planet's ozone layer can be destroyed by a particular type of supernova years after the explosion, according to a recent study that adds a new potential danger. Giant stars can briefly reach some of the highest luminosities in the universe when they explode in a large explosion known as supernovae. The brightest of hundreds of billions of stars combined can be eclipsed by a single supernova. Will the Earth be destroyed by a Betelgeuse supernova? The star will be the second brightest object in our sky after the Sun when the supernova occurs, despite being away from us. Betelgeuse, which shines brighter than a full moon, will be visible during the day. It will be so dazzling for a few weeks at the peak of the explosion that shadows will even be cast in pitch darkness. Despite its terrifying brilliance, the visible light emission from a supernova constitutes only a small amount of its total energy output. Furthermore, although exposure to high levels of visible light can result in blindness, it generally does not have many other detrimental impacts. The high energy radiation associated with the supernova, which generally takes the form of X-rays and gamma rays, is more of a concern. This high energy radiation has the ability to catalyze the removal of oxygen from the ozone layer that protects the Earth. Without the ozone layer, life on Earth's surface would be exposed to the full force of the sun's ultraviolet radiation, which could result in an extinction event in the first few seconds of a supernova. After the initial outburst of radiation, a greater threat emerges over time. Eventually, hundreds or millions of years later, cosmic rays, which are subatomic particles accelerated to nearby the speed of light, emerge from the maelstrom. They can also shatter ozone layers and blanket the planet's surface with deadly radiation, in addition to carrying with them a considerable part of the total energy of the supernova. Such events could have occurred in the past. Significant levels of iron-60, a radioactive isotope of iron created in the supernovae, are found in cores of the seafloor and lunar regolith. According to the analysis, iron-60 is a sign that the Earth was recently hit by a supernova ejector, possibly within the last few million years. Astronomers have previously determined that we are fairly certain there are no close supernova candidates that could endanger life on Earth based on the dangers posed by gamma rays and cosmic rays. But astronomers have discovered an additional possible risk. A specific type of supernova has the potential to emit deadly radiation that is additional, long-range, and dangerous to worlds like Earth. When a star nearing the end of its life is surrounded by a substantial disk of material, a specific kind of supernova arises. A shockwave is generated after the initial explosion of the supernova and strikes that disk. This shockwave causes the disk to become extremely hot, which in turn leads to the disk to generate a large amount of X-ray radiation. This radiation has a high energy density and a very long travel range. The brightest X-ray supernovae can overload a planet's ozone layer, depleting it by as much as 50%, which is more than enough to trigger an extinction event within a staggering 150 light-years radius. Such supernovae would deliver a lethal blow. A fragile planet would be bombarded by X-ray months and years after the initial outburst. Then, cosmic rays would arrive hundreds of thousands of years later and complete the task before the biosphere had time to recover and replace its protected shell. Fortunately, no candidate X-ray supernovae have been found to be close to Earth, but the galactic habitable zone, the area in each galaxy where life can exist, is now subject to additional constraints as a result of this research. Star formation is insufficiently high in the outermost regions of a galaxy, to produce the elements needed to generate rocky planets. However, dense star centers, where stars live and die rapidly, are equally dangerous because frequent supernovae irradiate the surrounding area. According to the new research, it is likely that the inner boundary of the galactic habitable zone is located farther away from the galaxy's core than previously thought. What will Betelgeuse supernova explosion look like from Earth? Earth biospheres will be unaffected, but that doesn't guarantee that no one will notice. According to Goldberg and Bolger, Betelgeuse will shine more than 3 months after its explosion with a luminosity comparable to that half of the Moon, 9 times fainter than the full Moon. A single point would contain all its luminosity, so it would look like a very bright beacon in the sky that could be seen during the day and cast shadows at night. It will be inevitable, and everyone on the planet will be fascinated by it. The supernova would be visible to people in the sky during the day for about a year, and as the supernova remnants fades, it will be visible to the naked eye for several years. If you liked the video, remember to like and subscribe, and I'll see you in the next one.